Hi everyone. Just a quick reminder that when you take notes and everything in the red, please jot it down just because it will help you remember a little bit better. And today we are going to talk about measures of center. And the most common one, measure of center, is the mean, MEAN. And the definition of that is there's a couple definitions. We're going to talk about both. One of them is a population mean, and the population mean is the point where the population histogram balances. Okay, and the symbol and the formula, mu, the little guy shaped like a U but called mu, equals summation x. And summation means adding every single thing related to x together. So in this case, you might see you might see the definitions. So sometimes I'm just gonna write it down for you guys. So summation, that's how it look like. It's called the sigma summation notation. Or we call it the sigma. It's a Greek letter. Okay. All right. So now what you have to do is also understand the definition of all the letters, and that will be really helpful. So the next thing it says the population mean will have the same units as the data set. Okay. And mu is a parameter statistics. Now, remember from before when we talk about parameter P and P. So P is stand for population. Statistics is the big picture. Since it is a numerical summary of a population or sample, okay? So in this case, N is stand for population. Now this N, if you notice, is a capital N. So the capital N is going to be representing the population. So the mu is going with the big N. Definition that related to the mean also, it's called the sample mean. That means you are taking a group not as big as a population, remember that? And then so that is making it easier to calculate. Most of the time we probably will use just the example mean because to calculate a population average is just way too hard. So example means is the point where the sample histogram balances, okay? And the formula and the symbol and the formula is going to be x with a bar over it, and that's equal to the summation of xi sub I, that's called sub, underneath is called sub, over little n. And if you look at it, the definition of that is the sample mean will have the same units as the data set. Okay, that means if it's a minute, whole bunch of data is minutes, then the units will also be minutes. If your data set with how many people, then the data set units will also be people. So X bar is the statistics since it is a numeric summary of a sample. So you have to understand when you have a mu is the parameter, and that's the population. And when you have an X bar, we call it X bar, that's the average of a statistic and sample. Okay. To do example number 1, you just have to add all the means together, all the x value in this case, or add all the value available, which is going to be 13 plus 15.6 plus 14 plus 5 plus 10 11.9. Now, since you counted as 1, 2, 3, 4, 5 numbers, you gotta make sure you divide by 5, and the answer come out to be 58.5. And if you divide by 5, the answer is gonna come out to be 11.7. And so therefore, your answer for the mean is 11.7. The next definition we're gonna talk about is median, MEDIAN. Mediums, the definition of median is the 50th percentile. That means about half of the data value are less than the median and half of the data value are greater than median. Finding the median of a distribution. So first of all, you have to list from the smallest to the largest. Okay. 2, if the number of observation is odd, is the middle observation. Okay. If the number is odd, and then it's going to be the middle one. If the number of observation is even, then the median is going to be the average. Again, average is from adding how many is there, divide by how many exist, okay, of the two middle observations. So we are going to do some examples on that, and those are the method. If it's odd, it's the middle one. If it's even, it's going to be two middle ones add together and divide by 2, okay? So here is example number 2. The waiting time in minutes before placing an order or compare for a random sample of people from each of 2 competing fast food restaurants. So in this case, we still have to go back and review all the old stuff. So I'm asking, what is your variable? If you don't want to see the answer, work through what is the variable and type of a variable right now. So the answer for the variable is the wait time. The type of variable is quantitative and continuous because, again, it's numerical, and continuous means they don't have gap in between. They don't just wait for 1 minute, 2 minutes. They can wait 1 minute to 30 seconds or 1 minute and 35 seconds. Anything could be happening in between the 1 and 2. So therefore, it's continuous. And to compute the example mean, example median of each set of data. So let's start with the example mean first. And to use the notation that's x bar, and that's equal to 5 plus 8 plus 20 plus 3 plus 4 plus 2 plus 5 plus 6 plus 7 plus 6. And then divide by 10 because that's how many data pieces there. And that's going to come out to be 66 over 10. And then 2 divided, that's 6.6. And the units is going to be minutes because those are time weighted. Okay? And that is a sample mean. To do the median, the definition is to put them in order first. So median is going to be in order. So you start with the smallest, 2, and you have 3, 4, 5, 6, 7, 8, and 20. Okay, now what people do is they will actually say, okay, the one in the front and cancel out with one in the back. So we do this way. Oh no, look, if we cancel out, then we will not left with anything in the middle. So this is the even amount of number because remember the information from before. If the number of observation is even, which is 10, then the median is the average of the two middle observation. So in this case, there's 10 of them. So to find the median, you are going to take the middle two, which is right here. Okay, and you are going to make sure you add them together and divide by 2. So that's going to be 5 plus 6 divided by 2. So the median is 5.5 minutes. 2, or data set B. And I will please pause it if you don't want to see the answers. But make sure you show your work because I will check it when I give you guys points for notes. The answer for data set B is going to be sample mean is going to be around 4.9. And the median is equal to 5. Please show your work. I'll be looking for them. So now, knowing those two methods, we are going to decide when a median or mean is going to be used. So when you have, looking at the graph, when you have a symmetric histogram, that means both sides kind of even, you use the mean. And then if you have a skewed histogram, you use the median. So example 3 says, for the given histogram, determine whether the mean is less than, greater than, or approximately equal to the median. Explain. So in this case, if you look at the first graph, you will notice that's a skewed histogram. Actually, it's skewed to the right. And then so in this case, we will be using a median. Now the second part asks, determine whether the mean is less than, greater than, or approximately equal to the median. Explain. Well, the reason to explain that is because if you look at the first pictures, when you add them all together, the large piece is going to compensate for the smaller pieces. So in this case, if you have median, mean is probably going to be right in the middle. Okay, because that's how you find them. So that's going to be the mean. But if you look at all the data pieces, well, the first data piece has 20 people. The second data piece has more than 25 people. But if you look at the end where the skew part is, they have less than 1. So in this case, because they have so little data pieces, when you're counting how many of them, 50 from the right hand side or 50 from the left hand side, that is going to bring down the median down to where the more data is. So data piece of a median is probably going to be on the side of where is the more data, which is where the curved line is. So in this case, if you think about it, okay, the median is going to be less than mean. And also, if you want to remember, is median is going to be where the curved line is. So when you have the higher curve, that's where the median is going to locate it. but mean is always going to be in the middle. So if you think about it that way, you will know medium is on where the fat side of the curve. Hopefully that will be helpful when you try to decide, is it large, greater than or less than. So in this case, medium is smaller than mean. Okay, if you look at the second picture, it's more like a symmetrical. So since it's symmetrical, we are going to use the mean. But the second question says whether mean is less than, greater than, or approximately equal to. Well, because they both ends of the graph compensate each other. So in this case, your mean is probably going to be in the middle. And then when you talk about compensation on both sides, you notice both ends have very little amount of data. Majority of data is in the middle. So in this case, probably the median is going to be also in the middle. So therefore, the mean in this case is going to equal to probably to median or very close to it. And that is how you can tell between the two pictures. Each of the following histogram state which measure of center should be used. Pause here. I will put down the answers, but you guys can check it after you write down your answer. Here are the answers, and I also stated which median and mean are they equal to each other or greater than or less than. I hope you guys also have an understanding on that. If you don't, please make a note and I'll be happy to explain it one more time in class if that's not clear. Next center we're going to talk about is mole. The definition for mole is the data value that occurs the most often in the set of raw data. Data can have more than one mode. Data can have no mode. If the data set have no mode, please write the word no mode. And then one other word that you guys want to keep in mind is modal class. That's the second definition. And the modal class means the class in the group data table with highest frequencies. So in this case, last time you guys taking the quiz and they have modal, they have unimodal, they have bimodal. That means if they have a bimodal, that means you have mole happen twice. And that same thing with data can have more than one mole from before. Okay, so let's take a look at the example. Let's take a look at the example. And in example 1, right here, it says the record high temperature. So if you're looking at the record high temperature, you will notice number 18 is the record high. And to answer the question is the mole class for the record high is going to be 110 degrees to 114 degrees. Okay, and then so forth and so forth. So please pause the video so you can try the other two examples. Here's the answer for the other two. The most frequently happen is number 8, the frequency, and the mole class is the blood type O. For the next one is the frequency happening most often is number 7 in the frequency column. So to match up A movies, number of PPV movies is number 8. So mole class is APPV movies. So the example 6, match the given information to the appropriate histogram. We kind of talked about this in the situation before. So just kind of recap that because I think that's probably one of the toughest one to figure out. Hopefully it's not so difficult reviewing it again. So now we are talking about mean. Don't forget mean is the average, which is about 68, which is right here. Okay, then the medium is 75, so it's up here. That is your medium. Now, the medium is going to be higher than mean, so it's got to be, first of all, it's going to be skew. So it's got to be this picture. Okay, and so the mean is going to be 68, and medium is going to be at 75. And the next one, the mean is going to be 45, and the medium is going to be 45. And I told you guys that if they are the same, they are pretty much symmetrical. So it's going to be, this one is going to be symmetrical. And that's going to be the mean. It's going to be around 45. And so is the medium at 45. Okay. This will be concluding of our section 4.1. If you guys have any question, please let me know in class next time when you see me. Thank you for watching.